What does it mean for a random effect to have variance? Technically, variance is the inverse of precision. So using these words, more variance equates to knowing less. Certainly in the case of linear models, the greater the residuals, the less precise are the model's predictions. So a linear model tries to predict values of a dependent variable from a weighted combination of a set of independent variables. If the residuals hold tight around 0, then the predictions of the model are pretty precise. If the residuals spread wide, then the model's predictions are imprecise. Here's the thing to meditate on. When we are talking about the variance of a random effect, the opposite of all this is true. The greater the spread of a random effect, the more knowledge we have. How can variance represent knowledge when it is defined as the deviation from what we would expect? It depends on what the deviations themselves mean. In an ordinary linear model, residuals are the difference between what we observed and what we predicted. In a multi-level model, random effects are the difference between what we predict in general and what we predict in particular. The fixed effect is the average effect for the whole sample, and the random effects store deviations from this average effect for each group or cluster in the data. The random effects are the adjustments that need to be made to an intercept or slope to make it more accurate for the clusters of observations in your dataset. The deviations themselves represent precision or specificity. Now, you only use random effects when you suspect these clusters exist, but you could be wrong. If you model random intercepts but your clusters are not meaningful, then the random effects will hold tight around 0. This is because if the clusters don't matter, then on average, they'll be average. Most of the deviations from the average fixed effect, then, will be close to 0. If the clusters are meaningful, then the observations that make up the cluster will be similar, and reliably so. If the clusters are meaningful, then they will reliably deviate further from the average fixed effect. This is a similar concept as in ANOVA, where between-group variance is compared to within-group variance to determine if observations are reliably clustered in groups. In other words, if you can predict where your deviations are moving to, then variance flips from representing ignorance to representing knowledge. The clusters represent attractors in the dependent variable, little local hotspots that are explainable by the structure of the world. So what do you think is the philosophical meaning of variance, if the interpretation of its magnitude depends on the context of the deviations? What does it imply for the clusters that are identified by your grouping variable? Let's think about that for a while paying attention to your breath, or the music, or the visuals, or any combination of these things. Thank you for joining me for this meditation.